Okay, so now we're moving to example 11, which is going to make this be a little more complicated. So it says we're going to apply our remainder theorem and deal with simultaneous equations. So we're going to end up getting two different equations. So it's mainly about taking each part that we know and simplifying it down as much as possible, and then eventually using those parts together to find our solution. So it says that we have p of x equal to 2x to the fourth plus ax cubed plus 2x squared plus bx minus 2, and it says where a and b are constants. So when p of x is divided by x minus 3, the remainder is 40. So we know that for x minus 3, we know that our remainder is 40. So what that tells us is that when we do p of b over a, this is going to equal 40. That's what we know. So we're going to go ahead, we're going to figure out what b is, we're going to figure out what a is, and then we are going to evaluate based off that. So based off this example, we know that a is going to be 1 and b is going to be 3, because we know that we have to have it in the, remember, ax minus b is the form for our divisor. So we end up with these two numbers. So we know based off this that so b over a equals 3 over 1, which is the same thing as 3. So we go ahead and say, okay, well, p of 3, this number, equals 40. Based off this statement right there. So we're going to go ahead and plug this stuff in and go ahead and try to solve this down. So for p of 3, so we're going to get p of 3. Okay, so we get, based off of our function up here, we're going to have 2 times 3 to the fourth plus our unknown a times 3 cubed plus 2 times 3 squared plus another unknown b to the times x, which is, again, 3, minus 2. That equals 40. So now we have to go through and solve this out. So this is all we're focusing on right now. So try to figure out and simplify the rest of the way. So 3 to the fourth is 81. 3 cubed is 27, so we're going to say plus 27a. 3 cubed, or excuse me, 3 squared is 9, so we get 2 times 9. And we have plus b times 3, which is 3b, minus 2 equals 40. So 2 times 81 is going to be 162. We have our plus 27a. We have 2 times 9 is 18. We have our plus 3b. We have our minus 2, and that equals 40. So if we put all our extra numbers together, we should have here, this is going to be 178 plus 27a plus 3b equals 40. And so we'll have 27a plus 3b equals 40 minus 178, which should be a negative 138. So this is our equation 1. This is for our first part. So we're going to come back and reference this later because we still need to go back and kind of plug in the rest of our numbers. So for our second part, which our second remainder said that when 2x minus 5, the remainder is 8. So we have, so for 2x minus 5, we have our remainder is 8. So that means that P of B over A equals 8. So based off of this info, we have our A value of 2, we have our B value of 5, and so B over A is going to be 5 halves. So we know here that P of 5 halves equals 8. And so we need to go through and kind of establish the rest of this. Okay? So based off earlier in the problem, we're going to have P of 5 halves. That is going to equal 2 times 5 halves to the 4th. And we have plus our unknown A times 5 halves cubed plus 2x squared, so this is going to be plus 2 times 5 halves squared plus bx, so we got plus p times 5 halves, and then we got minus 2, and that equals 8. Sorry, running out of room here. So now we just need to simplify this stuff. So we've got 2 times, so 5 halves to the 4th power. 5 to the 4th is 625. 2 to the 4th power is 16. We then add. So we've got A times, so 5 cubed is 125 over 8 times A. Then add, so 5 halves squared is 25 over 4. B times 5 halves is going to be 5 halves B. And we have minus 2 equals 8. So lots of computation, but we're just going to keep on moving along. So 2 times this, so we can kind of cancel these out, and we're going to get 625 over 8. We have 100 plus 125 over 8a. We can simplify that. 2 multiplying by 2 and dividing by 4 ends up just us dividing by 2 overall. So this is plus 25 halves plus 5 halves b minus 2 equals 8. So we just kind of want to continue to simplify as much as we can. We have these 3 parts that we need to put together. So I'm going to rewrite everything in terms of it being over 8. So here, 25 halves, if we want it to be over 8, we have to multiply by 4 over 4 on top and bottom. So this here is going to become 100 eighths. That's 25 times 4 over 2 times 4. Our negative 2, we have to multiply that by 8 on top and bottom. So we're going to get, on top, is going to be a negative 16 halves. And then we have our plus 125 over 8a, and our plus 5 halves b, and that equals 8. Okay. So we then kind of continue down. We're going to end up here. We're going to put all of this, should be over 8, apologize. So we're going to put all this together. So this becomes 725 here, minus 16 is going to be 709. So we get 709 over 8 plus our 125 over 8 alpha, or A, plus 5 halves B equals 8. And then subtract that over, we're going to get 125A over 8 plus 5 halves B equals 8 minus 709 over 8. So we get 125 over 8A plus 5 halves B equals, well, this 8 is the same thing as 64/8 if we upconvert it, so minus 709 over 8. We get 125 over 8 alpha plus 5 halves beta, or B, sorry, equals, if you do 64 minus 709, we should get this to be negative 645 over 8. So this is equation 2. Okay, so we now need to put both of our equations together. So if we look back, we have, I'm going to go all the way back to the top, right, to our equation 1, and that's 27A plus 3B equals negative 138. So we've got 27A plus 3B equals negative 138. And then we also have 125 over 8A plus 5 halves B equals negative 645 over 8. So we need to put these two equations together in order to solve these. Okay, so what you need to do is you need to solve for one of these in both sides, and just kind of continue to work as best you can. So what I'm going to do is I am going to say, because of its complicated nature at this point in time, you can set this up into what is a matrix. And so this is something new that we haven't quite covered, but we can put these two equations together. So it's 27A plus 3B equals negative 138, and we have 125 over 8A plus 5 halves B equals negative 648, excuse me, it's 45 over 8. So we can set this up into a matrix. And so basically you're just going to take out the A's, and you're going to list just the coefficients. So we get 27, we get 125 over 8, we get 3, we get 5 halves, and then over here we get negative 138 over negative 645 over 8. So what we're going to do is we're going to put this into our calculator, and it's going to tell us what our A and B are. And those are the only solutions to the equation. So these are matrices are used to help solve simultaneous equations, and we're going to use that feature of our calculator. Now you can do this by hand, and it's just a little bit more complex. So we're going to go to matrix, which is second, this button right here, and we're going to edit matrix A, and this is going to be, it's rows by columns, so we have 3 rows, or excuse me, said that wrong. It's right, rows by columns, so we've got 2 rows by 3 columns, and we just need to type our numbers in. So we've got 27 here, we had 3 B's, and then we had negative 138, and then we had 125 over 8 for our A. It converts it to a decimal, which is fine. And we had 5 halves B, so we had 5 halves B. And this, it was negative 645 divided by 8. So this is our matrix. So now what we're going to do is we're going to do a feature of our matrix called row reduction. And so when we do row reduction form, it'll basically tell us our answer. So we're going to go to second matrix. We're going to go over to math. There should be an option lower down that says RREF. And we're going to do RREF of our matrix A. And when we hit enter, it comes down and it says 1, 0, negative 5, and 0, 1, negative 1. Well, when we set up our matrix, our A's are represented in our far left column, our B's are our middle column, and our values are the left. So what this really tells us right now is that A is going to be negative 5 and B is going to be negative 1. So we got, A to be negative 5 and B to be negative 1. Now this is a very detailed question. It is going to be very complicated to do by hand. You have to set it up in this form in order to use the matrix. You have to go ahead and have it set up to where you have the A's and B's both on one side. This method works for any type of equation, but it's very, very helpful tool when you can kind of anticipate lots and lots of very difficult arithmetic to do. But you have to have it set up in this form first, and so in order to do that, you have to follow those procedures that we did before. But this saved us a good deal of time knowing how to use this function. So if you have questions about the row reduction or the matrix solution to solving this, please ask. I'll be in class to do that. Otherwise, you can do this by hand by either doing substitution or doing other row reduction or function addition. But this, in my opinion, is by far the best method to use for this.